All right, Unit 1, Day 6, recording on August 18th. I like to say that. That way if you're watching at home, I try to label them as well in Schoology. But if you miss a day and you start a video, you'll know, yeah, that's the day I missed. I'm watching the right video. Again, I try to label them, so that'll help as well. Function compositions. I kind of don't like that we've called it function compositions. And let me tell you why. We're going to do composition, but a better way to say it is function algebra. And then within that algebra, we'll do add and subtract. That's easy. We'll do multiply and divide. That's a little bit harder. And then we'll do composition as part of that. So we are going to, it's not that we're not doing composition, it's just that it's not the only thing we're doing. It's a subset of what we're doing. So retitle the notes, I think, to make it make more sense, at least to me. Roman numeral 1 is the arithmetic combination. You peek ahead, Roman numeral 2 is composition. Arithmetic, that just means add, subtract, multiply, divide. So we'll go through this section pretty quick because I think you know how to add, subtract, multiply, and divide. Now, it's not numbers, it's equations, but again, you know how to add, subtract, multiply, and divide with equations, so this isn't too bad. Let's skip f plus g, let's do f minus g. Why would I want to do f minus g rather than f plus g? What's the mistake people are going to make?
Because for minus g, you're going to do FOIL it out.
Not FOIL, I know what you mean.
Like, apply it to...
Apply what to? There you go. Apply the negative. It's fine to say it that way. Distribute would be the fancier word. But yes, apply the negative to everything. And so that would be the common mistake, is to not put parentheses or just forget to apply. So minus x squared plus 1. And then if we combine like terms, negative x squared plus 2x minus 2. By the way, this is just trying to say that those are exactly the same thing. You can just write it two different ways. F of x minus g of x is the same thing as f minus g of x. So it's supposed to make things less confusing, but sometimes I wonder if it's made it more confusing. Same thing here. F of x times g of x, that's the same thing as f times g of x. Hey, speaking of foiling, I have to foil that one. So first is 2x cubed, outside minus 2x, inside minus 3x squared, and last plus 3. And there's one minor thing that's not wrong about that answer, but it probably wouldn't look like that on a multiple choice test. What's not? It's not that it's wrong. It's just it's not in order, the order that we usually like. But if you got that far and then you started looking at multiple choice answers, I think you'd figure it out. Right? F divided by g. Well, f of x divided by g of x, or f over g of x. Again, those mean the same thing. And while division is usually the hardest of the operations, for functions, it's usually the easiest. Because what can I do with 2x minus 3 over x squared minus 1? That's kind of a trick question. What can I do with that? Can't take out an x. Can't simplify an x. I could factor the bottom, but nothing would cancel, and so that's kind of it. There's nothing to do. Now, I like that you saw that you could cancel because you can factor, because potentially after you factored you could cancel, but this one couldn't. So a lot of times division is the easiest of the operations because once you write it, there's nothing else you can do and you're just done. with one exception. Speaking of factoring, we have to think about domain, especially when we're dividing, because you can't divide by 0. So that means x can't be, what would make that denominator 0? Plus or minus 1. And so you could either factor to get there, you could set that equal to 0 to get there, or you could just look at that and figure out, yep, if I plugged in 1 or negative 1, I'd be dividing by 0, and I can't do that. So division is easy to do because there's really not much to do, but it usually leads to a domain issue because you've definitely put something in the denominator, and you have to be careful about denominators. That's what this dot says right here. The domain of a combination of function consists of all real numbers that are common to the domains of f and g. That's fine. The thing we're worried about is you can't divide by 0. So if there's something in the denominator now, you got to think about that. All right, composition of functions. I think you did this as well. So we'll slow down a little bit, but assume that you've done this. If you're given f and g, you can find f of g of x. That's how we would say that. F of g of x. Or g of f of x. And another way to write f of g of x is f with that little open circle. Yeah, so sometimes we call these the Fogg and Goff problems, because g of f we could write like that. So Fogg and Goff. Yes, foggy day on the golf course. I don't really like the Fogg and Goff notation because I think students get backwards as to what you do first. So whenever I see F-O-G or Fogg, I will change it to F of G of X. Because most people don't get that backwards. They know that you got to work from the inside out. Like that's how you do math. Parentheses first and kind of work your way out. So F of G of X, G of X is 4 minus x squared. So G is now the input into the F equation. All right, just like f of 3 means plug in 3, and f of 7 means plug in 7, and f of 12 means plug in 12. F of 4 minus x squared means plug in 4 minus x squared. And then combine like terms, negative x squared plus 6. Goff, again, if you're comfortable with the Fogg and Goff notation, fine, roll with it. I just think it's easier to make sure I'm doing the right thing if I do G of f of x. To me, it's clear that f is now the input to the G function. So you're tempted to read it left to right when it says Goff or Fogg. You're more likely to get it right if you've got parentheses. In my opinion, do with that what you will. So f is x plus 2. That means x plus 2 is now the input to the G equation. So 4 minus input squared. That's going to be a little bit more work because I'll have to FOIL and combine like terms and all that. But same process. Fill in the inside first. This is a place where you could get in trouble if you try to do too much. I'm going to FOIL and then distribute the minus sign. X squared plus 4x minus, no, plus 4. Right, because you don't just square the pieces. You got to FOIL it and get that middle term in there. I will skip a step. I'm not going to show distributing the negative sign. I'll distribute and collect like terms all at once. Negative x squared, negative 4x, then that's it, because the 4 minus 4 goes away. Say that again? I just distributed the negative because the negative came from the g equation, 4 minus input squared. 4 minus input squared. So I squared the input, attached the negative to everybody, and then realized that 4 minus 4 would go away. Why don't you try f of x? X plus 4. Questions on that one? G of g is kind of the same deal. You end up having to square something ugly. Gog. Yeah, there you go. Foth and Gog, as well as Fog and Goff. And then you can also have 3, so you could really start making some funny words. Fogoff of 2 is what f is. Let's skip D, let's do E, because that's a number in there. F of g of negative 2. So my first job is to find g of negative 2. Get that and plug that into the f equation. This is where showing your work, you got to show some, but I know some of you are going to show as little as possible. G of negative 2. So if I put in negative 2, square it, I get 4. 4 minus 4 is 0. And then f of 0, plug in 0, I get 2. Now, could you have done all of that without showing any work? Maybe, but that was like 4 things to do. And, the more things you do in your head, the more likely you are to skip something or miss something or forget a minus sign. So please show your work. Why don't you try the fog off question here? Well, that almost sounded bad. You okay with that? I mean, do I need to go over it? So start from the inside, f of 2. So you look at the f function and you plug in 2. 2 plus 2 is 4. So I'm going to replace f of 2 with 4 because the function evaluated at 2 is equal to 4. All right, well, we back up one step. Now I want to find g of 4. So I go to the g function. I plug in 4. 4 minus 16 is negative 12. So I'm going to replace g of 4 with negative 12. But then negative 12 becomes the input to the f function. So I go to the f function and I plug in negative 12. I think the test has already been written, so this is not going to be the bonus. But every year I want to make the bonus on this section something like, however many equations, something like that, where it's not really that hard. You just got to keep up with what's f of 1, and then what's g of that, and then what's g of that, and then what's f of that, and f of that, and g of that. And so it's none of them would be that hard. You'd just be like, can you keep up with all the pieces till you get to the end? All right, domain of the composition. The domain of f of g is the set of all x in the domain of g such that g of x is in the domain of f. I know, it's like, huh? I'm going to phrase it this way. So f of g of x, you need to check the domain of g of x of the inside, but also check the domain of the result of f of g of x. And then you got to go with whatever's the most restrictive. So everybody gets veto power. If you can't go there, if one guy says you can't go there, then you can't go there. You have to use this sort of overlapping. It's got to be okay for both domains to be in the overall domain. Okay, example 3, f of g of x. So not worried about domain yet, just f of x squared which means the square root of x squared minus 2. Okay, so the domain of f of g of x. So I kind of have to worry about both of them here. Not kind of. I do have to worry about both of them. The inside and the overall. So the inside, what's the domain of g of x?
X squared.
Well, that's what g of x is equal to. What's the domain of x squared? All real numbers. You can plug in anything you like there. Okay, so g doesn't have any restrictions. He's fine with whatever. But f of g, now we've got a square root, which means I got to be careful because square roots have to be greater than or equal to 0. So I'm going to have to do a little work here. X squared is greater than or equal to 2. Let's be careful about just tossing on the square roots and the plus or minus on there, because that inequality is kind of messing things up. So one answer would be x is greater than or equal to the square root of 2. That would get me a number greater than 2 if I squared that. But the other side, if I square root both sides, I'd get a negative. But I would want it to be, or I'd be concerned about x being less than negative square root of 2. And it's not I. I happens when negative's on the inside. Number line. I need to be less than negative square root of 2 or more than square root of 2. Because when I square those, then the values get big enough to be more than 2.
So it's going to be negative infinity, then square root to square root of 2. Or would it be negative?
The negative square root of 2.
And then union
Yep.
square root of 2, or negative square root of 2.
No, positive square root of 2
Okay.
to infinity.
Yes.
Yes.
Because it would be probably x squared on that side, like the square root of, and then it's a, if it's a possible square root.
When you do a square root, you got to do plus or minus, but that inequality means you better be very, very careful about which way we're going. Let's do g of f of x. Again, I really don't like Goff, so I'm going to rewrite it. G of square root of x minus 2, which means square root of x minus 2 squared. Well, what's the square root of x minus 2 squared? The square root of x minus 2 squared is just x minus 2. Because the square and square root cancel each other out. Okay, so the inside is f, and that domain, oh, let's be careful here. F is just square root of x minus 2, so that means x minus 2 has to be greater than 0, x has to be greater than or equal to 2. F of g, like, whoops, not f of g, but g of f, what's the domain of that? What's the domain of x minus 2? What am I allowed to plug in there? Anything you want. Okay, so overall the domain is all real numbers, but before we got to that, we had to say x has to be greater than 2. So we got to go with the more restrictive one. So the overall domain is x has to be greater than or equal to 2. Another way to do this is to take the domain before you do any simplifying. So you start there, and you're like, well, they cancel each other out, but I wouldn't even be able to get anywhere if I had a negative in there. So you either do a two-step deal of check the inside, check the overall, or you can check the overall before you do any simplifying. Let's do number 4. 1116, right? Yeah, we're good. F of g of x. Okay, so the inside is g, the overall is f of g. So f of x plus 5. So that's 4 over 3 minus x plus 5. So 4 over negative x minus 2. How to show, or different ways to think about the inside and think about the overall. So the inside is g. G is x plus 5. What's the domain of x plus 5? It's all real numbers. We can do whatever we want in there. That's fine. But the domain of the overall, whoops, I better be careful. I can't divide by 0. Negative x minus 2 can't be 0. So move things around, and x can't be negative 2. So my inside guy says, yeah, do whatever you want. The overall says, well, wait a minute, you can't use negative 2. So my overall domain then is x can't be negative 2. With what? Oh, the interval notation?
Yeah.
You don't have to. I mean, it would be negative infinity to negative 2, negative 2 to infinity. All right, g of f of x. G of 4 over 3 minus x. And you could think about the inside right here before you do anything, if you want to kind of do them both at the same time. Like kind of work the problem in parallel. So x can't be 3. And then if I plug that in for x, 4 over 3 minus x plus 5. Well, that domain is still can't be 3 because there's a 3 in the bottom there, or x minus 3 minus x in the bottom. So, however we want to say it, the overall domain, x can't be 3. But it couldn't be 3 from the get-go. And so whatever else happened to f, because it was the inside function, x would never be able to be 3 regardless of what happened after that. So that domain thing is tricky. Check the inside and then check the overall. All right, these are supposed to be easy, but somehow students forget how to use a graph to find the value of a function. So f of g of 3. This is so frustrating in calculus when students can't do this. F of g of 3. So we'll see if you're going to frustrate me or not. What's g of 3? Good. Right? That means the x value is 3. I'm looking on the graph of g. Y value is negative 2. So these are supposed to go quick, but you got to know how to read the graph and what you're looking for. How about f of negative 2? What's that equal to? So the x value is negative 2. I'm looking at the graph of f. So the answer is negative 1.
I have a question. How
Yes?
do you get negative 2 on f of g and make like 3? That's my question.
So how do I know g of 3 is negative 2?
Yeah.
Okay, so the inside number is the x value, right? And it's on the function g. So I need to go to x equals 3 on the g equation. So x equals 3 on the g equation is right there, and that y value is negative 2.
But it says like addition, so.
Oh my goodness, yes, I did the harder thing. It's like, it says addition. So that just means f of 3 plus g of 3. Good catch, thank you. So f of 3 now. Alex, you tell me, what's f of 3 now that you know how to do this? Pardon?
Negative 2.
F of 3. So x is 3 on the graph of f. So go to x equals 3 on the graph of f. And what do you see? X equals 3 on the graph of f is 3. And then x equals 3 on the graph of g is negative 2. 3 minus 2 is 1. F divided by g, so that means f of 4 minus g of 4. So why don't you try that one? So try E, g of f of negative 4. We already did one like that. We did it wrong, but so find f of negative 4, and that becomes the input to g.